Welcome to the third live session of design of reinforced concrete structures, and we shall discuss few things on this. So, obviously that whatever the questions you have, and then today just please allow me to give some time, so that we can discuss the whole course and exam all those things. So, let us start with the last week's question, whatever we have. You have any question? Huh? So, I think we discussed this particular question, that difference between going depth, trade depth and rise depth. So, we mean to say whenever we talk this particular one, then let me put it like this regarding the staircase. So, we talk this one you say trade, and this one we call it rise. Now, whenever we talk rise depth, depth corresponds to this one, there is no such problem. This is the depth. Now, there is a confusion, it may arise that whenever we talk say trade width, it is supposed to be width, but whenever we talk trade width, then it may come in this fashion also. That means, if we look, you are going up this direction. So, this width also people can think of it, that what is that this width. So, there are two width, one with respect to this, since we are talking horizontal, and this one also horizontal. So, that way there is a confusion, that is why we call it actually trade depth, this one, or going depth, the one we talk it say something like this with including the nose. Then we consider the nose part and going. So, this is the going, that way we can consider. So, we mean to say this is the one we consider depth that way, just to avoid this confusion with the width. Width of the staircase may be say 1200 millimeter or 1000 millimeter. So, people can, where a trade something around say 250 millimeter and rise something about say 150 millimeter. So, considering that aspect, to avoid this confusion, I generally prefer to give the trade depth, that means this particular millimeter. Regarding the step, if there may be that somehow other I could not get any other alternative vocabulary by which I can use it. So, this is the one that we mean to say, but rise the depth, obviously there should not be any kind of problem. So, you have any other question? Okay. So, now let us come back that a few things let us discuss, that will be easier, that if we talk. I thought of making few things. So, let me tell you something how we generally solve the problem. Let us say that please show the computer. So, if you really consider that, so just let me make it little bigger. Okay, now I think it will be all right. So, let us say this is a problem that we make it. First, let me tell you the most of the things actually I have done it using that programming, because all the things, as you can see this particular one, that everything that I have done it by programming, and so you will get certain kind of that your systematic way you can get it. So, here the problem generally whatever problem we require, very few problems we require. Number one obviously we are going for say working stress method, and you are talking say limit state method. And if you really consider as limit state method, though we call it the working stress method, is also a subset of limit state method, that way you can get, because here also there is certain limit in the stresses. So, that is why the working stress method also you can call it. Now, if you really say that a problem, which problem you would like to do? First one, the problem you are going to solve singly reinforced section. That means that even though the reinforcement at the top, you will not consider that. Second one, we have doubly reinforced section. And third one, we are having, say, let us consider T section, and for this case we have three cases. Number 1, neutral axis within flange. This is the simplest one. Your life is also very easy, because it is nothing but you will consider this one as a rectangular beam. The other one, we are having cases where neutral axis in wave, but flange in rectangular stress block, and third one, that is the most difficult one to calculate, neutral axis in wave and flange partly in rectangular part. So, these are the three cases that we consider here. So, if we are coming back again, water tanks, if you really consider that water tanks, that one we do it in working stress method, because you can consider the sections, it should be uncracked section, so that there should not be no water, no leakage. But if you really consider bridges, they are considered actually here nowadays in limit state method also, and this is given actually, so far India concerned, IRC 112. This is the latest code, which is in 2011 published. So, here though we are having that working stress method also, limit state method, but working stress method has gone to appendix, limit state method, and this is a very interesting thing, you know, that once you are asking this question, just let me explain this particular one. For this is your, say, XU. This is 0.45 FCK. Now, this value is how much? 0.36. If you remember 0.36 FCK B, then XU by D into D, something like that, XU, that particular one that particular one will come, sorry, XU will come, B into XU will come. Now, whenever you are getting this particular value, then what I shall do it here, this particular one, this one I can make it a very interesting trick that is done here. We take a rectangular cross section, this is 0.45 FCK, and this value is supposed to be 0.36, because as per this I cannot change this value. So, what we do it? We use a parameter lambda, and this lambda equal to 0.8. So, that means if we take 0.8 this particular one here, you will get this one, you will get, that means 0.45 FCK into lambda x should be equal to 0.36 FCK, whatever the value we are getting here, FCK B XU. So, that particular one we should get it. So, whenever we should get this particular value here, you see that one, if lambda equal to 0.8, then you will get this one as 0.36. So, that way that IRC as well as Eurocode also, both the codes now they do it, and IRC 112 they make it like that. Even if you do it in IS 456 also, that is, but the code does not allow us to take this type of thing. But please note, this one actually we do it for T beam, that when the neutral axis that is in wave and that flange partly in rectangular portion and partly in what is called in the that your parabolic portion, that way actually we do this particular one here. So, this is the one that trick you can, and that way what will you know, that way it is very easy that this portion will become actually lambda by 2 x u, which is nothing but 0.4 x u. Remember, in earlier case here it was 0.416 or 0.42. So, here you are getting 0.4. So, there is little change, and this particular one is very useful, that means no need of going all those things, that your calculation everything becomes very simple. This is the thing we do it. Okay. Calculator, I think that calculator will be available as per the that in the computer itself, the way calculator available, that one will be available here. But regarding IS code, IS codes are not allowed. Relevant tables, data will be supplied. So, you need not worry for that. But say for example, but you have to remember span by depth 20, span by depth, say for example, you are talking span by depth 20, that you have to remember for simply supported beam. Then 7 cantilever, then you are having 26 continuous. So, those value it is expected you remember. If you do not remember, you will never actually remember that one for your whole life. So, it is better to remember at this age, because whatever I am talking, all those things I did it my BTech in 1983, from that time onwards. So, that time actually in our college also the codes were not allowed. So, we went through all the things, and that way we are remembering that way we are remembering. So, that is why I am telling you that your BTech things, if you just make it that one say systematic way, then you will honestly speaking there is not much things to remember was given, but in practice how the calculate torsion in a beam due to cantilever slab or from a secondary beam, please explain. So, if we consider this one, say your a projection of slab. So, I can consider this particular one, whatever moment we are getting here, that moment we shall consider here. So, I can take it here also for this particular one here. So, this particular moment it is coming, that will be torsion in the beam. So, that means the in the portico or in the front there you generally find out that your cantilever slab. So, that one will have a continue the torsion load torsion on the beam in addition to a self weight and other load there. Okay. This is the one that you are telling why we check compressive strength of concrete in cube form, while inside concrete are either in form of cylinder or cube. So, actually cylinder and your cube both of them can be used, but IS 456 actually states that go for cube, and obviously we have to follow that one. But there is there are few other countries where they follow actually cylinder, and cylinder will give you a conservative result, you know, because if you consider the cylinder. So, this is actually it is coming say 150 millimeter, and this is 300 millimeter, sorry 300 millimeter. So, you will get something like this 75, here say you are getting 75. So, this is unsupported length, and because of that your cylinder strength that compared to cube it will be less. So, that way you can say that is in the conservative side. So, maybe one day in IS 456 that will be there. So, I cannot say because it is suggested by recommended by a committee, and that committee obviously knowledgeable one. So, I cannot say that why you are using that particular one. So, let us take that particular one here, that we are actually that our quality of concrete good, you can say that way. Those who are having the cylinder, that way you can say that it is that way, that in a lighter moment I can say. But anyway, when we are talking that cube, since as per our Codal provision, so let us follow that. If I am designing the ground floor column and first floor column, what are the total loads I need to take for design of in G+4 building? Please show the example. So, let us start with this. So, we are here, this is your plinth beam, first floor, second, third, G+4, so fourth, and then you are having roof. So, this is your thing. Let us say from here to here something you are getting say let us say 2.5 meter, considering that it may be 3 meter also considered. Generally in normal cases it comes 1.2 meter like that, that is the one they follow, but let us say it will come 2.5 meter because I am considering this particular floor so many. Now, let us say this is your say 3 meter, another one 3 meter. I am taking simple way 3 meter. In few cases this particular floor that it comes more little, maybe 3.5 like that also we consider. So, now here you are having slab, wall load, floor finish like that you are having. So, let us say slab 125 millimeter thick, floor finish 100 millimeter, then wall it can be 125 millimeter thick or 250 millimeter thick. Then self weight of beam rib, because though we are talking this particular one. So, this portion you have taken as a part of slab. If you take, then only you take the rib portion. So, now in the plinth, if you do not have any slab, so that load will not come into picture, but your wall load will come. So, and that one, let us say slab, wall load, floor finish, then plaster. So, whatever load you are having, which may be say 12 millimeter, 6 millimeter thick. So, slab you take 25 kilonewton per meter cube unit weight. This one you can take 24, somewhere you can take actually 22, like that, it all depends on that. Wall 20, this is again 25 kilonewton per meter cube, based on that you can take it. So, you can find out the load from here. So, this particular you are getting that one, say your slab, wall load, floor finish, plastering, all the loads whatever coming actually on this particular you can take. That means, if you say this is the one elevation, and let us say I am taking a plan and I am interested for this column, here one column, here one column, let us say here one, here one. So, you can take this load like this, from this case you can find out how much load is coming on this beam. Half of this beam will go here, half of this beam will come here, half of this will come here. So, that means I can get it something like this. This is the load which will come here, half from this side, half from this side, like that. And whatever load are coming for the beam, that also you can take it. Self weight of the column also will take it. So, now for the second floor the same thing, third floor also same thing, fourth floor also. On the roof there is no wall, in the roof there is no wall. So, only you will consider that particular one here, say slab, floor finish, plaster, but your roof treatment will be there. So, that you can find out the roof treatment, which may be sometimes it may be say 150 millimeter thick also, it may be lime terracing also. Nowadays we use something else. So, this type of thing which may be say 200 millimeter, 300 millimeter also it goes. So, that weight also you have to consider. So, whatever load are coming, all those things you can find out. The idea is that whenever you are considering a building, say this is a building, the plan, and there are so many. Now, the question is, let us say you are having columns 300 by 500 millimeter. Question is, how shall I place the column? Shall we place it like this, or shall we place it like this? So, this is 300 and this is 300. So, which one is preferable? Now, obviously, the thing is that it is possible, because if we due to wind or earthquake, it will vibrate like this, because this side weaker, it will vibrate like this. So, if we consider that, so obviously to resist that we shall prefer this one, then only I can counter that resistance. If we make this particular one, then your resistance this side is less, because B d cube by 12 and d b cube by 12. So, obviously that here d b cube by 12 is more than. So, here according to this, about this axis, here I am getting say d b cube by 12, but whereas here I am getting b d cube by 12. Why this one will move like that? Again the same principle, you consider this length and consider this length. So, obviously, here this side that moment of inertia is the second moment area or whatever you call it, that is more than compared to this side. So, that is why it will bend like that, and to overcome that situation we require this type of that column position. Sometimes we use it from the point of view practical requirement, but from the technical point of view obviously this should be used like that. How to check whether there is torsion is being applied and we should give torsion reinforcement. So, how to check that one? Generally nowadays that particular one you have to see whether that particularly say cantilever beam, other things, whenever we consider that one, obviously it gives torsion, that is the one general rule. Alternatively nowadays we use say software for analysis, and from there you can find out whether any torsion is there or not. That way you can find out, and on the basis of that you find out the equivalent bending moment and equivalent shear force, and on the basis of that you can calculate. We have given number of trade, we have given, right? Huh? We are coming back. For design of continuous beam or slab, the bending moment and shear force coefficients are given to us, or have to no, it will be given, that value will be given to you, that your coefficient, other things, whatever, that will be given to you. Okay. Now, let us I think we have discussed this staircase actually. Let us say this is the thing that we considered here. So, we shall find out that effective let us consider that your just please give the show the computer. So, let us go through that your code, then it will be easier. So, obviously, please note, just when I have opened that code, let me give you idea. The thing is that one is that, before coming to that, let me first let us just note down those clauses at least, so that you will remember. Say 5.6.3, so that is the one is given 200 kilonewton per millimeter square, the modulus of elasticity of that your steel. Concrete, you should know, please show the computer, 5000 root FCK, please show the computer, hello, 5000 root FCK, that is the value we can consider. So, we can find out here, excuse me, please show the computer, that is computer screen, please show the computer screen. So, we can consider that particular one here 5000 root FCK, this value that you should remember. I am just telling you that from which code or what you should remember, that let me tell you first. Then there are so many tables, all those things we do not require actually, just I am going through one by one. So, because these are mainly formwork, other things, whatever that, all those things are there. But it is expected you go through this one once, it will be easier. Say for example, quantity of concrete in the work 1 to 5, number of samples 1, 6 to 15, number of samples 2, like that. You can actually that at least you should remember few of them. That FCK plus 0.825 established standard, that also you should remember, that is your say table 11, just this value 0.825 or 3 certain values that it is expected actually remember. Now, whenever we are coming to this, that I have told you effective span, so you are talking this table. So, this table you need not remember, it will be supplied, it will be given to you, that relevant value will be given to you. But this value you should remember, because it is very simple to remember L 0 by 6 and L 0 by 12. So, like that this value at least I have told you this value also you should remember 7, 20, 26, there certain value up to 10 meter, like that at least you should go through, you remember. But this table whatever the relevant portion, that one will be given. This is simply supported slab 35, continuous slab 40. So, those things it is expected you just remember that particular one. So, like that say this formula L equal to phi sigma st by 4 tau bd, that also you should remember. These values, some values that will be given. Now, the spacing or reinforcement, other things that at least you should remember. Diameter of the bar if the diameters are equal, diameter of the larger bar if the diameters are unequal. 26.3.2 clause 26.3.2, those clauses that you nominal cover, that also it is expected you remember. So, spacing of shear reinforcement, other things that is very simple, that you can know. Minimum reinforcement 0.15% of the total cross section area. Please note that whenever you are talking slab, you are talking actually total cross sectional area, not the effective. So, like that it is expected that you go through this problem, then it will be clear to you that particular one you can find out actually here. So, just you go through once and most of the cases you will be able to remember that. This portion is not so that it will be, that we are talking this particular course very elementary, that is why you shall consider actually a very simple things only we shall give. So, this portion will not be there, these particular clauses. So, whenever you are talking this particular one here, so let me just make it bigger. So, if you see that we are getting that going, and this is the thickness that what we have to y plus y. So, x less than 1 meter, y less than 1 meter, x less than 1 meter, y greater than 1 meter. x greater than 1 meter, less than 1 meter, less 1 meter. So, like that. So, you can get different value of span g plus x plus y, g plus x plus 1, g plus y plus 1, g plus 1 plus 1. So, like that you can get it. So, that means you can get the span you can find out here. Now, whenever you are coming to this one, just let me tell you. So, corresponding load you calculate and solve this problem. Most of the cases we consider this one as W L square by 10, that is a very common practice, but if you want to really like to do this program with certain boundary condition, because it is not exactly simply supported, that is why we do not get actually W L square by 8. So, if you give that program, say for example, if you would like to further do it, most of the cases you will find out this portion actually supported by 2 beams in both sides. So, whenever you are considering that beam, that one beam here, another beam here, so like that you are having. So, we can, this is one column, this is one, you can consider this one as a fixed, and then we can have column. So, like that you can consider here that as if you are having this one. If you really would like to do it, then I can consider this one, we can consider here that plan, and then you can solve it. But because this particular one, with respect to that we can find out what is the fixity, it is not fully fixed, that is why I cannot go actually here W L square by 12 here I shall not be able to achieve. So, there is a certain relaxation because of certain moment, because that if it is fully fixed, it is W L square by 12, then here it will be W L square by 24, but that is not the case. So, that is why we may consider this one, neither we consider fully simply supported nor we consider fixed. So, with that way, that is the very common that we consider as W L square by 10. Okay, so it is a very, which software is used for slab, column and beam design? There are so many softwares available in the market, and you can choose any one of them and you buy according to your pocket, whatever available in your pocket. But anyway, the thing is that you can try on your own. I shall show you, just today at least I shall show you that how we are doing. I am doing everything now in actually in Python, and through this there is one processor that is called actually LaTeX. So, from Python I am just generating LaTeX file, the text file we call it, and that one if you just process it by any text, that software, the text typesetting program which is available actually. One is that actually I use it MikTeX. So, if you use that program, so that you can get that PDF file. So, that way you can try on your own so that you can understand how it works actually. It is a very simple way and you can learn Python in no time. If you are really interested, you can download it. There are so many things are available in YouTube, and then you can do that particular one. If you are interested, then you can mail me so that I can give you basic initial part, I can give you a Python file so that you can start on your own. In the formula dead load of staircase, why we need to divide by G? Because divide by G means you will get per meter. This one gives actually per meter length. Instead of taking that width, so you are getting per meter length, and that is the thing we do it here. So, this is the one, that formula whatever we have given, that particular one, say W into B plus RT by 2 into 25 by G, that is the one formula whatever we have discussed earlier also. Let me quickly go through this one, because I have got a few mail, actually I have forgotten his name. but that he has nicely has told me. So, let me tell you just one problem that which I have started actually here in the very beginning. So, let me show you this particular one here. So, let us say this is just simply is now the thing is that as I have started in the very beginning, I can see this particular one that I do not want to everything. So, that means your this course number, rectangular beam, then August 21 the date actually when I created this particular one here. So, everything will be given, that problem 1, all those things, this figure, everything is given. So, I am going to determine the limiting moment of resistance of RC rectangular beam section as shown in figure 1, and data given B equal to 250 millimeter, overall depth D equal to 5 millimeter, clear cover 25 millimeter, tensile reinforcement 4 numbers of 20 millimeter. So, I would like to make it in a systematic way. So, solution to problem 1, concrete grade M20, steel grade Fe415, capacity strength of concrete, from here you can say 20 Newton per square millimeter, strength of reinforcing steel FY 415 Newton per square millimeter, width of beam B 250 millimeter, overall depth D 500 millimeter, clear cover CC, that one variable I am giving 25 millimeter, tensile reinforcement bar dia phi T 20 millimeter. So, area of tensile reinforcement NT into NT is 4 pi 20 square by 4. So, 1256.6 square millimeter. Then effective rate D, the way we write down D minus CC minus phi T by 2. So, 500 minus 25 minus 20 by 2. So, 465 millimeter. Neutral axis factor XU by D epsilon C by epsilon C plus epsilon S 0.48, which is given in code also. Position of neutral axis from the compensation side, that means from the top, XU B by D into this one 0.48 into 465. So, 220. That means, if you are asked that one say neutral axis for the compensation side for the balance section. So, this is the result, possibly one problem or such kind of thing given. Compressive force K1 FCK B XU B 0.36 in 20 into 250 into 220.8. So, you can find out this is in Newton. So, you convert into kilonewton. Area of steel balance section ASTB CCUB 0.87 FY 401.0. So, that means, so this is the compressive force, so it should be balanced by that one. So, you require actually 1110.8 millimeter. So, you are actually provided, how much you have provided? 1256. So, you are providing here, but actual requirement how much? 1110.8. So, moment of resistance due to concrete K1 FCK B XU B D minus K2 XU by B. There are so many ways can be written. It can be XU by D. So, this formula, just let me show you this formula once more. So, MUCB, that balanced K1 FCK B XU B D minus K2 XUB. This is the formula. So, I can write down here K1 FCK B XUB by D. So, I should have 1 D here. Then, if I remove, take it out this D, 1 minus K2 XUB by D into D square. So, 1 D here, another. So, that means, this is the formula we can get it here. So, this portion I can write down here like this K1 XU by D into 1 minus K2 XU B by D into FCK B D square. So, this is nothing but for case 0.138 FCK B. So, that means, for different value you can get that particular one XU by D for different steel you will value will be different and these value will be different. For Fe415 this is 0.138. So, you can remember that one, or you can come to the first principle. So, what I have done here, if you now see the screen, that you can see this particular one here, please go to the screen. Yes. So, K1 FCK BXU, the whatever I have shown here, the same thing here I have written like this. So, you put the value here 149.320 into 10^6 Newton per meter, 149.320 kilonewton meter. So, this is the value you can get it here. So, area of steel provided as over-reinforced. Why? Because provided area of steel AST is greater than balanced area of steel ASTB. So, therefore, this is 1256.6 and 11 requirement for balance this one, that means. So, this is the one provided. So, momentary resistance for that particular one is over-reinforced section. If it is not, then I shall get it the other way, I should get this particular one here. So, that means here what I mean to say that if you really write your own program and in a systematic manner, maybe you may think little bit difficult for the time being, but what I have done actually, you think of it that you are writing those files in a particular format and which is in a text format I have written, and text will just make all of them here. You try to learn LaTeX also, that way it will be easier. And you can see that way the way we calculate, first you give the formula, then you put the value and then you calculate the value. So, everywhere, so that means even if you do it, you will find out that it is a very limited choice. So, when you have a limited choice, so then this is only 3 line. So, like that you can consider. So, like that if you just think of it, it is very easy to make it actually. So, everywhere you are having one header, like that you can make it. Let me show you another problem. This is the another problem. Unfortunately, the problem I thought of making is doubly reinforced, but somehow other when I have come that I found that okay, anyway this is also very interesting one, you will find out. So, let me show you this particular problem. It is very difficult to make it. So, let me put it some more, zoom it. So, a doubly reinforced RCC beam section as shown is here, this is figure 1 here, only one, has the following details: width of beam section 300 millimeter, then gross depth of beam 500 millimeter, effective cover compression and tensile 50 millimeter, the tension and compression reinforcement of the beam section 3 numbers of 16 millimeter, and 5 numbers of 16 millimeter. Sorry, it will be reversed actually, that 3 and 5 that were actually tension will be 5 numbers and compression that one actually 3. So, this is the one actually that way the written, and whenever you are considering this, let us find out again the same fashion I have done it: concrete grade, steel grade, capacity strength of concrete, FCK, reinforced FOI, width of beam B 300, overall of D 500, clear cover, that one I have taken 42 because just I have considered that, though it is given 50 millimeter, because I have taken 60 millimeter, from there I have got it that value. Now, you see this one that I have written this particular one here just to give you idea. I hope you will be able to see that computation and composition through programming in Python. So, like that it comes actually every page. So, that means this particular one that I have done it actually. So, like that actually you can make it here. Anyway, coming to this particular one here, so we can find out those things here. Again the same way, area of steel, compressive reinforcement, effective depth, because I have taken that effective, though effective depth is given, effective cover is given. So, that way I have just divided. So, which is nothing but 50. So, that I have made it. Effective clear cover, that is 50 millimeter, whatever actually they have given. On the compression side, again that is 50 millimeter. Neutral axis, that 0.48. Position neutral axis the same way, 215.6. this particular one it comes every page, I need not write. So, automatically the program will do it. Compressive force in balance section you can find out here this much. Then area of steel of balance section. So, compressive force divided by that 0.87, this is the value it will give, this particular value we are getting. So, that means 16 1200.5 millimeter square is given. Moment of resistance due to concrete. So, again the same way you can find out the formula whatever we have done it. Moment of resistance due to steel, the same way you can get it here. So, 153.24, that particular you can get it. So, moment of resistance of the section that we can find out here. So, MUCB and MUS, because it is more and this is less. So, this particular value is coming. So, that means the section is under reinforced in this case. So, what you have to do then to make it doubly reinforced section, the section should be initially the section should be actually your over reinforced section, then only it can come into picture. We are coming to back to that particular one again, that, but this is the one that we can find out. Is there any difference in the design of beams that comes over the slabs or inside the slab? Okay. So, first of all, this is a common practice, it is like this, let us say the other side also. This is a general situation. There are certain cases also you can find out like this. So, if you consider the design, in this case if you really consider that you are actually that if that thing is that compression, that one again at the top. So, you have to provide reinforcement that way, the same way you provide, you do not want to show, that one from the bottom, here you can show that, but you do not want to show here. So, sometimes we do it here. So, then what is happening that your compression side, that your say L beam effect will not be there. So, only you will consider this one as a rectangular beam, that way only you will consider here, this particular one that we can consider. Now, if it happens, this is the slab, at the end you would like to make, I cannot give like this. So, whenever you are providing that one here say stirrup, then obviously that portion will become as a behave as a beam. Sometimes we inside also we make it, there is no such division, but if we provide this one say your stirrup, with that you can find out it will be treated as that. So, that means what is the general guideline? Slab bending only. We do not provide any shear reinforcement. So, slabs, that is why slabs should have a certain thickness. If I go more thickness, then shear force will come into picture. That is another interesting thing. So, that is why the slab we should have, then beam, bending and shear, and here we provide stirrups. So, even if it is inside the slab, so you demarcate that particular one, which one, which portion you are giving that one as a stirrup. So, that portion you can consider as a beam. Similarly, if you consider column, then we are having axial and axial plus bending. So, this is the one that we consider, that we generally consider in our say design. So, for design of RC structures, it will be 100 marks, Out of that 75 marks will be taken from exam, 25 from assignment, that one. Now, you are having 20 questions, 1 mark, then 20 questions, 2 marks. This one mainly one equation that we can consider, and remaining you are having actually remaining. So, this is your 20, this is 40. So, remaining 40, this one 4 or 5 marks like that you can consider, that is the one we can consider that way. So, that means if it is 5 marks 8 questions, if it is 4 marks then 10 questions, and that question may have 2 or 3 or 4 equations, that way you can find out, that is the thing you can consider. Okay, there are so many books are available. Recently I have found one book on Monish Shikhonde. So, is the last week over? Huh? Oh, there is one actually in the last week. You will find out that multi-storied actually building design also, but there is one book available that Monish Shikhonde, that with the earthquake resistant design, that certain problems are given. Also, you will find out actually in that your say what is called IIT Kanpur, that site, there also that you will find out that your certain that your design also available, but you will find out certain document also, that whatever we shall give in NPTEL, that last week course that I shall give. So, these are the things that we shall now. Let us come back to again that wind up all those things whatever we would like to consider. SP 16 obviously will not be required. So, just we shall come back with the last few minutes, that if you really consider. So, we have discussed all those things. So, just you remember this formula, that will be sufficient, that whatever formula are given, that is sufficient, and this few formula that is given, that I have shown in the very beginning, on the very first day itself. So, like that you can find out, you can consider that. So, that is the one I can say, and now let us go back to that IS 456 whatever we are having in the limit state method. So, these few 1.2, 1.5 those factors that you should remember. This particular one you can remember that FCK 0.67 FCK 0.67 FCK by gamma m. Just let me make it little bigger. So, this is the one you can consider. So, this particular one 0.42, 0.36, that also you remember, 0.361 or 0.36 you can remember, 0.0035 that also you should remember, 0.002, 0.0035 that we should remember. There are many questions regarding that your say column. So, this particular one, please try to understand this particular one. This is a very important one for the that your say column design. And you can see this one XU max by D 250, 0.53, 415, 0.48 and 500, 0.46 that you can find out here for different value, because 0.48, because of that you are getting 0.138 FCK BD square. There are certain formula there. This type of formula also you should remember, what is the additional moment that is coming. You should remember that one also in the column. There are two things formula there. One is 0.4 FCK AC 0.67, that whenever you are talking axial one, then you are considering this one. This is PU. But whenever you are considering that one, say for calculation of bending, that biaxial bending, then PUZ 0.45 FCK AC plus 0.75 FY SSC. So, Please remember there is a basic difference between this one, that is for axial one where eccentricity other things considered, and the other one you are talking when you are talking say biaxial bending, there 0.45 FCKSC, 0.75 FYSC. So, this particular one that you remember, that the question if it is asked, please note that particular one what question is. Additional moment, obviously you remember this particular formula. Then obviously this formula VU by BD that you have to remember, this formula also you have to remember if it is given. This table you need not remember, that values if it is required it will be given. This formula you have to remember, VUS 0.87 FYS V by D, or if it is say what is called that inclined, then you have to consider this particular one. So, with this I think and this formula also you should remember, and this one also. So, you find out those formula whatever we are available. So, and it is very easy that if you remember this one now, then you will remember it for your whole life. So, I think that is there any other question? So, I think that we have completed our session, the third session also. So, with this what I can say now that so let us say this particular one, what I can say that with this that whatever the things you have covered, that your assignment other things. So, the questions also similar fashion like that, and you go through it, you go through SP 60 sorry SP IS 456, and relevant data will be given from the table other things. And with this I think I can say now at this moment best of luck for exam. Thank you very much.